right, students, in this video, we're going to go over how to assign oxidation numbers. Now, when you're given just a reaction, you have to determine what these oxidation numbers are in order to determine what's being oxidized and what's being reduced, and then to figure out the oxidizing agents and the reducing agents. So this is our first step in analyzing an oxidation reduction reaction. So there's a few different things that we are going to look at, some rules, if you will, for assigning oxidation numbers. So first off, the oxidation number of a monatomic ion is equal to its charge. So if you look at just an ionic compound where there's no polyatomic ion involved, it's just a metal and a nonmetal. Whatever its charge is its oxidation number. So halogens are always -1. The alkali metals are always +1. The alkaline earth metals are always +2. And you can determine those transition metals from the charge of the nonmetal. So in this example of the iron chloride, the Fe is a +2 ion, so its oxidation number is +2. The chlorine is a halogen, so it's going to have a -1 charge. The oxidation number of hydrogen is usually always going to be a +1. The only time when hydrogen is not a +1 is when it's a hydride, and that would be a -1 charge. And the hydrides are going to be when the hydrogen is bonded to a metal. So in the example of sodium hydride here, NaH, the hydrogen would have a -1 charge. Okay, so but typically the hydrogen is going to have a +1 charge. Oxidation number of oxygen is usually going to be -2, its usual charge from the periodic table, except when oxygen is in a peroxide. And that's when the oxygen is bonded to something from group 1 or hydrogen. Okay, so like hydrogen peroxide, that's an example of a peroxide that we're all familiar with. In hydrogen peroxide, the oxygen charge is -1 instead of -2. If it's a free element, so it's not bonded together to anything, its oxidation number is going to be 0, and it doesn't matter what its subscript is. So sometimes you could see something like S8 or P5. Those oxidation numbers are still going to be 0 because it's still a free element and it's not bonded with anything else. When you have a neutral compound, the sum of the oxidation numbers is 0, and that's going to be helpful for us if we're dealing with something that has a polyatomic ion in there and there's something sandwiched right in the middle of two other things. Okay, so the sum of the oxidation numbers is 0. If we're looking at a polyatomic ion, the sum of the oxidation numbers is going to equal its charge. So we have SO4 -2 here. The charge, -2, is going to be what the sum of those oxidation numbers is equal to, and that's going to help us to figure out what that sulfur is. Because we know that oxygen is always -2, and we have 4 total oxygens, so we know that we have a -8 from all of those oxygens. So if -8 plus something has to equal -2, then that something, that sulfur, has to be a +6. Okay? All right, so let's practice here. Looking here, we've got P2O5. So we know that oxygen is always going to be -2, so we're going to start there with the -2. And we know that the sum has to equal 0. So we have 10 total negatives from our 5 oxygens. So our 2 phosphorus have to equal +10. So the phosphorus has to be a +5 then. Okay, in water here, we know that H is always +1 and oxygen is always -2. In our ammonia, we want to keep in mind this charge up here, the sum has to be equal to +1. We know that hydrogen is always going to be +1. I always start with the ones that I know for certain are always going to be that oxidation number. Since I have 4 oxygens, I have a total of +4. I need to equal a +1 overall, so my nitrogen has to be a -3. So they end up with 1 positive left over. So I've got sodium dichromate down here. I know that that sodium is always going to be +1. I know my oxygen is always going to be -2. okay? So I've got +2 total for my sodiums, plus I'm going to have 2 times something to be the oxidation number of my chromium, excuse me. And then I've got 14 total negatives from my oxygens, and that all has to equal 0. So my 2 chromiums have to equal +12. So each chromium is going to equal +6. And that's the charge of my chromium there, my oxidation number, excuse me, of my chromium. I've got calcium hydroxide. This one's fairly easy because I know calcium is always going to be +2. Oxygen is always -2. And hydrogen is always +1. Okay? So let's take a look at these questions here. We're going to combine assigning oxidation numbers with determining whether or not something is oxidized or reduced. Okay? So we're going to write the oxidation numbers above each symbol in our chemical reaction. So I'm going to look at each compound separately. So I know that this oxygen is -2. So this copper, because it's Cu2, has to be +1. This oxygen is -2. So the nitrogen has to be +2. I know in here, this oxygen has to be -2. So this copper, since it's just CuO, has to be +2. And then this nitrogen, because it's by itself, has a 0 oxidation state. So now I can figure out what's oxidized and what's reduced. Remember, oxidized means that it lost electrons, reduced means that it gained electrons. So which one lost electrons? The copper lost electrons. The copper is oxidized because it went from +1 to +2. Okay, it got more positive, it lost electrons. What was reduced then was our nitrogen, because it went from +2 to 0. It got more negative, so it gained electrons. All right, let's look at this example over here, the aluminum oxide one. So I know that aluminum is going to be +3, oxygen's -2. Remember, if it's just a simple ionic compound, I can use their charges from the periodic table. Carbon's by itself, so it's 0. Nitrogen's by itself, so it's 0. I've got another ionic compound, so this is +3 and -3. And then I've got carbon monoxide. So oxygen is -2, as we know. So then the carbon is +2. Now notice this carbon is not this charge from the periodic table. This is a +2 because the oxygen is always a -2. I got the oxygen's oxidation number first. So we want to figure out what's oxidized and what's reduced. Well, let's look at our oxidation numbers. Which one lost electrons? Which one got more positive? The carbon is oxidized because it went from a 0 oxidation state to a +2. What's reduced, what got more negative, is the nitrogen because it went from a 0 oxidation state to a -3. Let's look at the silver example here. I see that this silver is by itself, so that's 0. I know that H is always +1, and oxygen is always -2. Now we got to figure out what the oxidation number for this nitrogen is right in the middle. And that nitrogen is going to be a +5. Okay? Because we've got 3 oxygens that are all -2, so that's -6 total. With the hydrogen, we've got a +1, so that's why the nitrogen has to be a +5. Silver nitrate, the silver here is going to be +1, and the oxygen is a -2, and I've got something with a polyatomic ion. I'm going to go solve the middle one last. So I've got, again, 3 oxygens, each having a -2 oxidation number, +1 with the silver, so this nitrogen is also going to be +5. This oxygen is -2, so this nitrogen has to be +2. Hydrogen's +1, oxygen's -2. So when I look at my oxidation numbers and I'm trying to see which one got oxidized, well, I can see that the silver is oxidized because it goes from 0 to +1. When I look to see which one is reduced, at first glance, it might be a little tricky because I don't see anything, but the nitrogen pops up in 2 places on the product side, and in that second place, it does get reduced because it goes from a +5 to a +2, and it gets more negative. The last example here, I know iodine has a 0 oxidation state here because it's by itself. Hydrogen's +1, oxygen is -2, so this chlorine is going to have to be a +1 as well. Water we know is +1 for the hydrogen, -2 for the oxygen. I've got a +1 for this hydrogen, a -2 for this oxygen. So then the iodine here, I've got total of 6 negative charges from those oxygens, +1 from the hydrogen, so the iodine has to be +5. And then I've got +1 on the hydrogen, -1 on the chlorine. So what's being oxidized? What's getting more positive? Well, it looks like the iodine is being oxidized because it goes from a 0 oxidation state to a +5 oxidation state. And the chlorine is being reduced because it's going from +1 on the reactant side to -1 on the product side. So that's how we determine if it's being oxidized or being reduced. Now, the other thing we can determine after we assign oxidation numbers is to determine what the oxidizing agent is and what the reducing agent is, okay? So the oxidizing agent is the substance that does the oxidizing. So it contains a substance that gets reduced. Now, when we were assigning oxidation numbers and determining what was oxidized and what was reduced, we were identifying a single element as being oxidized or reduced. When we identify the agents, we are identifying the whole compound, the whole reactant that has a substance that's doing the oxidizing or doing the reducing, okay? So the reducing agent is the substance that's going to cause the reducing, so it's going to be the substance that is oxidized. And again, we're looking for the whole compound, okay? So when we look at this example here, we're trying to figure out what's being oxidized and what's being reduced so that we can identify the agents. We're going to first assign our oxidation numbers. So this is 0, and this is 0 because they're both free. The sodium is +1, and the chlorine is -1. So what's oxidized? Well, we can look at our oxidation numbers, and we can see that the sodium is oxidized because it went from 0 to +1. What's reduced, we see is the chlorine because it went from 0 to -1. So our oxidizing agent is going to be the chlorine gas, the Cl2, because that's what's causing the oxidation. And the reducing agent then is going to be the sodium because that caused the reduction. So looking at this example, let me draw my arrow. We're going to first assign oxidation numbers. That's where you should always start. So the hydrogen is +1, the oxygen is -2. So this nitrogen is going to have a what oxidation number? +5. Then the hydrogen here is going to be +1, the iodine is -1. Over here on the product side, oxygen is -2, so this nitrogen has to be +2. This iodine is going to be 0, and then water +1, -2. So what is oxidized? What lost electrons? Well, we can see that the thing that got more positive is going to be the iodine because it went from -1 to 0. What's reduced? What got more negative? Well, I can see that the nitrogen got reduced because it went from +5 down to +2. Notice here when I identified what's oxidized and what's reduced, I put just a single element. But now that I'm going to identify the oxidizing agent, I'm going to put the whole compound. So the oxidizing agent is the reactant in which has the reduced substance. So this is going to be HNO. I'm going to put that whole compound because the HNO3 caused the oxidation. The reducing agent is going to be the HI because it has the substance that was oxidized. It caused the reduction. Okay? So here, let's do another example. So we've got +2 for this lead, -2 for the oxygen. What is this sulfur's oxidation number? We've got 8 total negatives from the oxygen, +2 from the lead. So sulfur has to be +6. Water, we should know by now, +1 and -2. This first lead is going to have an oxidation number of 0. This lead, let's do the oxygen first. Oxygen is -2. So this lead has to be +4 because you have 2 oxygens. And then we have sulfuric acid over here. The hydrogen is +1. The oxygen is -2. So what's sulfur's oxidation number here? Well, we've got 8 total negatives, 2 total positives. So sulfur has to be +6. So what's oxidized? What got more positive? What lost electrons? The Pb, because it goes from +2 to +4. What was reduced? What got more negative? Well, it's also the Pb, because it goes from +2 to 0. So we have lead in 2 places on the product side, so that's why it's oxidized and reduced here. So our oxidizing agent and reducing agent are going to be the same thing. It's going to be the PbSO4. It's not going to be the water because the water was not involved. The hydrogen and the oxygen were not involved in the oxidation or the reduction. Okay, so this type of reaction is called disproportionation because the same substance was oxidized and reduced. Okay, so what I want you to do is I want you to go back to these reactions that we did initially, and I want you to identify what the oxidizing agent is and what the reducing agent is. And then I want you to check back on the PowerPoint to see if you got those correct. And let me know how you're doing and if y'all have any questions.